Hey, it's Mr. P. with Algebra 2. This is Unit 3, Topic 1, SLT number 1, which we are doing an introduction into trigonometry. And we're focusing on sine functions. To find the height of a right triangle, so this is a right triangle, so we know that Pythagorean theorem should work, so which means a squared plus b squared equals c squared. But in this case, we don't have two of the sides, so we only have this angle and this one side. Now, the three trig functions you should have learned in the past are sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, in this case, we have the opposite side, which is across from the angle. It's not next to. Adjacent means next to. And the hypotenuse is always the longest side. So we have the opposite side and the hypotenuse, which means that we have to use sine functions. So sine of 32 is equal to x over 18. Now, in order to solve for x, you always do the inverse operation. Inverse of dividing by 18 would be multiplying by 18. And that's what you're going to put into your calculator. So you're simply going to multiply 18 times sine of 32. And make sure that your calculator is in degrees if you go to the mode. And that's what it should look like. Oh, there we go. So we have an answer of 9.53 or 9.54 if I round that to the nearest hundredth. Number 2 over here. Once again, I have the opposite side and I have the hypotenuse. So sine of 59 is equal to opposite over hypotenuse. Multiply both sides by 28. So I'm doing 28 times sine of 59. And I get about 24. X is 24. All right. So in this lesson, we're going to be doing a lot of the Ferris wheel and a lot of these videos that you're going to see. So Carlos is afraid of the heights, but he wants to ride a Ferris wheel. He finds out the wheel has a radius of 25. So that means the distance from here to here is 25. And he also knows that the center is 30 feet above the ground. So that's the height here. How high will he be at the highest point on the Ferris wheel? Well, if the center is 30 feet and the radius of any circle is always the same length no matter which direction you're going, so then this length is also 25. So that's 30 plus 25 makes 55. How high will he be at the bottom of the wheel? So the bottom of the wheel would be the center height minus the radius. So that's 30 minus 25, which gives us 5. How high will he be at the position on the far left or far right? Well, on the far right-hand side, it makes a rectangle because this spoke right here is parallel to the base. So therefore, opposite sides must be the same. So if this is 30 feet high, then this spoke is also 30 feet high. All right, so we already found points A and F because A and F are both 30 feet high as it was in that question. So if this is 30, this is 30 feet high. We already said that this will be 5 feet, and then the highest point we already said was 55 feet. But we're trying to find now these other points. So we already found A and F. How high are they off the ground? So is there another point that will be the same distance to the ground as point B? So point E is the same height. So B and E are the same position around the circle. So we already found the A and F. How high are they off the ground? So A and F we already said was 30. How about point C? Point C is the same as D. Point J will be the same height as G, and point I will be the same height as J. So now that we've covered that, so if we can find B, then we know that E is exactly the same. So what we're going to do is we're going to create this spoke. We're going to turn it into a right triangle. Because if we have a right triangle with spoke A, then we know that A squared plus B squared equals C squared. So in other words, this length plus this length equals this length squared. Now, in this case, we're trying to find the height of this side. And what we can do is we can figure out how big this angle is. Because we know a full circle is 360 degrees, then we know that if a full circle is 360 degrees and you divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections, then you know it's 36 degrees per section. So now I know this is a 36 degree angle, assuming that all of these spokes are equal distance. Now, using that, we can use, just like the warm-up, we can use sine of 36 is equal to x over 25. So just like the warm-up, multiply both sides by 25. So 25 times sine of 36 gives us about 14.7. So now we know that the triangle, or x, is 14.7. That doesn't mean that position B is 14.7. That just means it's 14.7 more than A. So therefore, if we add 14.7 plus the center height, which was 30. So if we add 30 to that, and then we get 44.7. And therefore, if B is 44.7, then E is also 44.7. Because like we said before, this position and this position are exactly the same. Now, if we can find C, then we know C and D are the same position. We already found A and F. We already found B and E. So we want to find the height of every single position all the way around the Ferris wheel. So if we can find C, then C and D must be exactly the same. Now this time, the triangle uses this angle right here is two pieces. So it's not just this piece right here, but it's also this piece right here. And like we said before, if each piece is 36 degrees, then this angle right here must be 36 degrees. So 36 times 2 gives us 72. So now we know that this is a 72 degree angle. We can then, okay, so this is, I just found this. So the height of the triangle will be sine of 72 is equal to x over 25. Now, once again, if I multiply both sides by 25, which is really just multiplying by the radius, which we'll learn later when we write the equation, times sine of 72, and that gives us 23.8, give or take. So the height of the triangle is 23.8, but once again, remember, we have to also add the center height, which is 30 more, and that gives us 53.8. So now we know that C is 53.8, then D is also 53.8. Now, that's really all the sine and cosines that we have to do, because if I erase this all out, these triangles that we've created, this triangle that was right here, actually I need to keep that, because this triangle right here and this triangle right here are exactly the same triangle, but they've been reflected. So whatever this height is, then this height has to be exactly the same. But this time it's not 23.8 more than the center height. Now it's 23.8 less than the center height. So I simply subtract and I get 6.2 is the height of I. And if I is 6.2, then so is H is 6.2. Now I could do the exact same thing for J, because remember this triangle right here is the same size as this triangle right here. So these are two, this height has to be the exact same as this height. So if this height was 14.7, so is this one. The center height was 30, so I do 30 minus 14.7. And that gives me a difference of, what is that, 15.3? Yeah. So that's going to be 15.3 is the height of J. And if J is 15.3, then so is G. All right. This is pretty much the same premise. You're going to find this triangle to find the height of B. Do the same thing for the height of C. And then you can use those two to find all the other positions. So what I would do in this question is I would start with the one that is easiest. In this Ferris wheel, the spokes are 30 feet and the height is 34 feet. So that tells me that A and, okay, I need to move myself, A and G are the same height as the center. So A must be 34 and so is G. So I'm going to start with the easiest ones first. Now, if this is 34 and I subtract the radius of the circle, then that tells me that J must be 34 minus 30 is 4. J is 4. Now, if this is 34 and this is 30 more, so that adds up to 64 is D. So those four positions are the easiest. The ones that are the same as the center height and the ones that are directly above and below. Now, if I can find the height of this triangle and the height of this triangle, I can find all the rest. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections going around. So there's 360 degrees in a circle. Divide that by 12 and you get 30 degrees per piece. So then to find B, you're going to do sine of 30 is equal to x over the radius, which is 30. Multiply both sides by 30. 30 times sine of 30 is 15. So if it's 15 plus the center height of 34, it means it adds up to 49. B is 49. And if B is 49, then so is F is 49. Now, like I said, if this is 15, then you also know that the height of this triangle is also 15. So therefore, it's 15 below the center. So 34, so I'm trying to find L now. So that's 34 for the center height. Minus 15 gives me a difference of 19. Yeah, 34. 1, 2, 3, yes. So 19 is the height of L, which means it's also the height of H. Now, I need to find one more triangle, and that's this triangle right here. If this was 30, then you know this full angle now is 2 pieces, is 60 degrees. So that's sine of 60, trying to find C. It doesn't really matter where I put it. So sine of a 60-degree angle is equal to x over 30. Multiply both sides by the radius. 30 times sine of 60 gives me 25, well, 26. I'm just going to say it's 26 exact. So 34 plus 26 more is 3, 4, 5, 60. So height of C is 60. And if C is 60, then E must also be 60. Now, if this is 26, then this triangle is also 26. So therefore, K's position is 26 below 34. 34 minus 26 gives me a difference of 8. And if K is 8, then so is I. And I think I'm going to wrap it up right there. Please give it a like to help you learn something about using the basics of sine when looking at a Ferris wheel, or a circle in this case. And we're going to get into further videos. We're going to get into actually following sine from the starting position, going around and finding any length all the way around using time, and you'll see. All right, thanks again for watching. Have a great day.